In this section, we will determine the amplitude, midline, and period of what is called a sinusoidal function. So what is a sinusoidal function? Well, as we've seen, sine and cosine functions have a regular period, which is what creates the graph's symmetry. An example of these sine and cosine functions would be in the pattern of ocean waves. But of course, we know that not all ocean waves are exactly alike. Some are taller or even longer than others. In math, such a variance in a sine or cosine function is called a sinusoidal function, where the general form of the sinusoidal functions are y equals a times the sine or cosine of the quantity b times the quantity x minus h, all plus k. Now notice that even though these are called sinusoidal functions, they don't involve just the sine function. They also involve the cosine function. Now, question. What do the changes to a, b, h, and k values, what do those do to the graphs of the sinusoidal functions? Well, a hint has to do with that example of the ocean waves, where we saw that not all ocean waves look the same. Some are taller or even longer. So that's what the a, b, and h and k do to the sinusoidal functions. They create those sorts of variances. Let's get a few definitions. We've seen that the period of a function is the shortest interval over which a function completes one full cycle. Here's a new definition. The midline is the horizontal line midway between the function's maximum and minimum values. The amplitude is the distance between the function's maximum and minimum value and the midline. Now, here's the question. Which one of those letters, A, B, H, and K, do these things represent? And that's what we'll explore in the next few examples. So let's take a look at the sine function and the cosine function and identify some of the characteristics that we just talked about. We'll begin with the midline. A midline is defined as the horizontal line between the function's minimum and maximum values. So whether you're dealing with a sine function or a cosine function, it looks like both of these graphs have their maximum at 1 and their minimum at -1, which means that the midline, it's that halfway point, is going to be the line y equals 0. The amplitude of the sine and cosine function is the distance between the function's maximum and minimum value and that midline. So if the midline on both of these is the line, the horizontal line, y equals 0, then from that midline, we see that the distance is 1. So that's the amplitude. And then finally, the period of the sine and cosine function is the shortest interval over which a function completes one full cycle. So for the sine function, we saw that if we start at the origin, we go up, we come down, and we begin that cycle again at 2 pi. For the cosine function, we start at the tallest, 0, 1, and we go down, and then we go up, starting that cycle over at 2 pi. That makes 2 pi the period for the sine and cosine function. Of course, if we're in degrees, then that would be 360 degrees. So let's explore the midline a little bit more. Here is the function y equals the cosine of x. And we have said that this one has a midline at the line y equals 0. We've said that it has an amplitude of 1, and we've said that it has a period of 2 pi. Of course, we can see all of that in this picture. Nothing new here. But let's change it up a little bit. What if we throw a +1 on the end? Now what are the midline, amplitude, and period? Let's see what changes. So if you have a graphing calculator or Desmos, that's what I'm using here, then you can put in exactly the function that we see listed. Y equals the cosine of x plus 1. And it's going to look like the picture that you see here that seems to have the same shape, but has shifted up a little bit. So let's see here. What is the midline? Well, the highest value on this black curve, the highest value is at 2, and the lowest value appears to be at 0. So halfway between there is going to be the line y equals 1. Y equals 1 is the midline. The amplitude, so sometimes if I sketch in that midline, it helps me to see the amplitude. The amplitude is still just going to be 1 because it is the distance from the midline. So the midline's changed, but the amplitude is not. It's the distance from the midline to that maximum or that minimum value. And then the period. Has the period changed? No, we're still, if we start at, say, 0, in this case, comma 2, we are still seeing that repeat down at 2 pi. So the period is still 2 pi. Let's look at another one. How about y equals the cosine of the quantity x minus 1/2? So we added 1 before. Now we're taking away 1/2. What is your guess about what might happen? Well, let's take a look at the graph. And here it is. Y equals the cosine of x minus 1/2. And now this function is below the original cosine function. How much is it below? Well, it looks like the largest value is happening here at 1/2. And the smallest value is happening at, what would that be, 1.5? So from 1.5, negative 1.5 to positive 1/2 is a distance of 2. So if I split that distance, it looks like I'm going to have a midline at y equals negative 1/2. From that negative 1/2, I go up, I go down, still the amplitude is 1, and still the period appears to be 2 pi, right? I can see that I'm still ending at 2 pi. So is there, what is the connection? So in the original form of the sine and cosine function, which was y equals a times the sine or cosine of the quantity b times the quantity x minus h, all plus k, we could say that the midline is represented by the line y equals, do you see what it was? When the midline was y equals 1, we had a plus 1 on the end. When the midline was y equals negative 1/2, we had a minus 1/2 on the end. So the midline is represented by whatever that k value is on the end. And the midline vertically shifts, it shifts the graph up if k is positive, and it shifts the graph down if k is negative. Now let's take a look at what is the amplitude. And we'll begin by looking at a graph that is becoming familiar to us, the graph of y equals the sine of x. And this graph, we had it starting at 0, 0, and it went up, it came down, and it ended or began to repeat at 2 pi. The midline, we said, was the line y equals 0, the amplitude was 1, and the period was 2 pi. Now let's look at a variation of that. How about we look at the graph of y equals 2 times the sine of x? Go ahead and put that into Desmos or put it into a graphing device. And when I did that, I got this picture of a graph that is in black. And the description that I would give for this picture would be a graph that has as its largest value, looks like 2. It's hitting its tallest value at 2, and it's hitting its lowest value at -2. It's like someone has stood above it and stretched it. So has the midline changed? Well, it's definitely taller, right? But between 2 and -2, still the halfway point would be the line y equals 0. So I don't see that the midline has changed. What has changed is the distance from the midline to that maximum and that minimum value, and that is changed to 2. Now, why am I not using -2? Because it's defined as a distance, and distance is always positive, all right? Now, what about the period? Has the period changed? And the answer is no. If I start at 0, 0, I go up, I come down, and I see myself repeating at 2 pi. So that has not changed at all. Okay, let's try another one. How about y equals 1/2 times the sine of x? Now, I can go ahead and graph this, and I will here in just a second, but do I need the graph in order to determine the midline? We said on the last slide that the midline is the number that is plus or minus on the end. And for the first example, y equals the sine of x, there's nothing there, so that's like a +0. For 2 times the sine of x, there's nothing on the end of that, so that's like a +0. Same thing's happening here. There's a +0 on the end. So I'm going to go ahead and say that the midline of y equals 1/2 times the sine of x is also y equals 0. And let's see if I'm right. Let's look at the picture of that. So looks very similar, very symmetric, only instead of being stretched like 2 times the sine of x, it looks to me like someone's squashing it down. It's compressing it. And the midline, like we said, it is at y equals 0, but now the highest value is at 1/2, and the lowest value is at -1/2. So I'm going to say that the amplitude is 1/2, and it has a period, it appears, nothing has changed there. We still have a period of 2 pi. So let's analyze this. So in y equals a times the sine or cosine of the quantity b times the quantity x minus h, all plus k, the amplitude is represented by, well, what do we want to say here? The amplitude was 1/2, and that was on the y equals 1/2 times the sine of x. So it looks like there's a connection between that number that is in front of the function and the amplitude. So in my formula, that would be the a value. So I'm going to write a here, and I'm going to do one more thing. I'm actually going to say the absolute value of a. Now, why am I saying absolute value? Well, because we could have a negative number on the front, but you might remember from maybe past experiences, when there's a negative number on, say, the outside of a function, all that does is cause a reflection, a horizontal reflection. But because amplitude represents a distance, and distance is always positive, that negative is going to have nothing to do with what we say is the amplitude. Okay, hopefully that makes some sense. So why absolute value? I think my answer would be because absolute value represents distance, and distance is always positive. Distance is always positive. Whether you walk forward or backward, you're going somewhere. So it's always positive. And we would say that the amplitude is vertically stretching. So it vertically stretches the graph if that absolute value of a is greater than 1. We saw that with the 2. And it is vertically compressing it, compresses, if that absolute value of a is less than 1. And we saw that with the 1/2. So midline is a shift, a vertical shift up or down. An amplitude is a vertical stretch or compress. Both of those are vertical changes. All right, now let's take a look at the period of a function and how that is affected by these numbers that are changing, in this case, the cosine function. So we start out with y equals the cosine of x, and we know that that has a midline of y equals 0. We know that it has an amplitude of 1. And in case it wasn't clear, you know, even though we don't see a 1 on the outside of that cosine of x, there is a 1 out there. So, you know, the absolute value of that 1 value is 1. If there were a negative in front of that, it would still have an amplitude of 1, but now it would just be a reflection, a horizontal reflection of this cosine function. The period is 2 pi. All right, so nothing new there. Now let's do some variations. What if we had y equals the cosine of the quantity 2x? Put that into your graphing device and see what kind of picture you get, or you can wait for me to hit the button, and there it is. Okay, so this is a lot to look at. What is happening? It looks like it got sort of skinnier, right? Sort of got compressed, but not compressed vertically, compressed horizontally. It's like people are standing on each end and pushing forward. Has the midline changed? Well, the midline has something to do with the highest and the lowest values, and you'll notice that my highest value is still up here at 1, and it's still down here at -1 for the lowest values. So the midline has not changed, which doesn't really surprise me because there's no number on the outside. How about the amplitude? Has the amplitude changed? Nope, that's still a 1, and I can tell that just by looking at the equation. So that's going to be 1. And by the way, the point of this is going to be that at some point you can just look at these equations and know what the midline and the amplitude are. We don't have to graph it every time. We're just using the graphs to sort of drive what's happening to these pictures. Now, what about the period? Has the period changed? If we pick a first point, let's just pick a first point at 0, 1. Okay, now we're looking at the graph of y equals the cosine of 2x. We see that curve go down and then come up and begin to repeat, not at 2 pi like it was before, but actually at pi. It's repeating at pi. So it's half of the period. So when we had a 2 on the inside of this function, in this argument, the period became half of what it was before. All right, let's remember that, and let's look at another example. Y equals the cosine of the quantity 1/2 x. Well, again, there's a plus 0 on the end, so I know the midline is going to be y equals 0. There's no number other than 1 in front of that cosine, so the amplitude should be 1. Now maybe make a guess as to what you think the period is based on what the period was for the cosine of 2x. Remember, for the cosine of 2x, we saw the period get cut in half, or divided by 2, right? Divided by 2. So what do you think is going to happen here? So hypothesize that, and now let's take a look at the graph. And there's going to be a lot to look at, so hold on. There it is in green. And instead of being pushed together, it looks like this one has been stretched out. Now, I agree that the midline is y equals 0. I agree that the amplitude is 1. If I start at 0, 1 and I look for where this thing repeats, I actually can't see it, right? The graph has been stretched out so much, I can't see the corresponding value that is, down here somewhere, or even to the left. So I got to try something else. I'm going to go down to -2 pi, -1. Here I am. And that's my lowest value. From that lowest value, I go up, I come down, and I begin to repeat at 2 pi. What is the distance between -2 pi and +2 pi? That distance is 4 pi, and that is the period. The period is the interval of which we begin to see that repeat. So was your hypothesis correct? If when there was a 2 on the inside, it divided it by 2, now when there's a 1/2, maybe it divides it by 1/2, and dividing by 1/2 is the same thing as multiplying by 2. And that works, doesn't it? So here's what we've got. In y equals a times the sine or cosine of the quantity b times the quantity x minus h, all plus k, the period is represented by, we're always going to start out with 2 pi, and then we're going to divide that by the absolute value of that b value. So that b value is the number inside that argument. Now, why absolute value? Same reason as it was before. We could have a negative number on the inside of that argument. We could have the cosine of -2x, but that's not going to change the period. All that that's going to do is it's going to cause a reflection. So we're not interested in the reflection, because even with a reflection, if we had a reflection, even with a reflection, we would still have that same period of 4 pi. So why absolute value? I would say that a negative b value only causes a reflection. It does not change the period. So we're going to say that the period horizontally stretches the graph if the absolute value of b is, let's see, the stretch came when the b value was 1/2. So we're going to say is less than 1, and it horizontally compresses it, squeezes it together when that absolute value of b is greater than 1. Okay, so at this point we've talked about midline, amplitude, and period. It's a lot. We've talked about the A, we've talked about the B, we've talked about the K. We haven't talked about the H yet, and we're going to hold off on that for just a second, because I think maybe it would be a good idea to do a few examples. So let's try that next. Identify the midline, amplitude, and period of a sinusoidal function. The first one, determine the midline, amplitude, and period of f of x equals -3 times the sine of x plus 2. All right, so I'm going to start with the midline. The midline, I know I'm going to write that as y equals something, and that something is the number that's hooked onto the end. So in this case, that's a plus 2, so the midline is y equals 2. The amplitude is going to be the absolute value of the number that's on the outside of the function. So the absolute value of -3 is +3. And finally, the period. The period is going to be 2 pi divided by whatever number is hooked onto that x, which in this case is 1. It's actually the absolute value of 1. And that is going to stay as 2 pi. So what we're working toward is to not only be able to identify these things, but then to be able to graph this function without using a calculator, just based off of the midline, the amplitude, and the period. Let's try another one. Determine the midline, amplitude, and period of g of x equals 4 times the cosine of the quantity pi over 2x. All right, what's the midline? Always going to be y equals something. And in this case, that something, there's nothing there, so we're going to call that a plus 0. So y equals 0 is the midline. The amplitude, what is the amplitude? The amplitude is the absolute value of the number on the outside, which is 4. And the period is going to be 2 pi divided by the absolute value of whatever is inside hooked onto that x, which in this case is pi over 2. Now, I would strongly suggest that instead of dividing by pi over 2, you multiply by its reciprocal. And when I multiply by the reciprocal, the pi's cancel out, and I'm left with a period of 4. So every 4 units, I'm going to see this g of x function begin to repeat. And one more, determine the midline, amplitude, and period of h of x equals -1 plus 5 times the sine of the quantity 5x. What is the midline? Now I put this one on here purposeful because not always are they going to be written with your, plus 2 or your plus 0. In this situation, we would want to rewrite this as 5 times the sine of the quantity 5x minus 1, if we want it in the same form. The thing to point out is that the midline is always the number that is added or subtracted from the original function. So in this case, that is a subtraction of 1. So I'm going to say that the midline is y equals -1. You might think of this also as plus a -1. That's another way to look at it. The amplitude, what is the amplitude? It is the absolute value of that number in front of the sine function. So the absolute value of 5 is 5. And finally, what is the period? The period is 2 pi divided by the absolute value of 5, which is just going to be 2 pi over 5. You can leave it like that.